Okay, Assalamualaikum and hi my year 9 students. So today this week we continue with still factors and polynomials chapter, the factor theorem. We continue with a few examples. I'm going to explain maybe one example in the first video, and then I'm going to give you 3 questions. One I will try to guide you, and then you will try to do at least 2 questions on your own. Okay, so before we start, I recap a bit about the factor theorem. So how do we show that some polynomials are the factor of some other polynomials? So how do we show that? So first, you need to make sure when you substitute that value into the value of x here, you will get equals to 0. So the factor theorem states that when you have something like this, you want to show that it's a factor. You let your x minus 3 equals to 0. So now your x is equals to 3. You substitute x equals to 3 into your polynomials and you should get 0. So if it is a factor, you should get 0. Okay, so let's substitute here. So you will get 3 power 3 minus 6, and then we have 3 square plus 11, and then I have 3 minus 6 equals to, you calculate everything, you should get equals to 0. So means that is a factor of that. Okay, so for this week, I hope you guys can do the exercise last week. So this week we are going to continue with another example on the application of the factor theorem. Okay, so this is the example that I want to discuss. Okay, 2x squared plus x minus 1 is a factor of that polynomial 2x cubed minus x squared plus ax plus b. So find the value of a and b. We want to calculate what is the a and what is the b. Okay, so first step is we know that that is a factor of that. Okay, remember I stated that when we have some polynomials is a factor of another polynomial, you let your x be the subject and you substitute into this one, and you should get a 0. Okay, but then now we have a quadratic function here. So how do we let x be the subject for that one? So first step is you let your 2x squared, okay, I change that, plus x minus 1 equals to 0. So how do we get the value of x, or how do I let x be the subject here? Is by using the calculator. How do we solve quadratic? Is by using EQN. So you press EQN. Okay, unknowns degree is 2 now. So your a is just 2. Your b is 1. Your c is negative 1. Okay, so you will get your x equals to 1 over 2, and another one is negative 1. Okay, so straight away we take x equals to 1 over 2, another x is equals to negative 1. Okay, means that when we substitute these two value of x into this polynomials equation, I should get a 0. Why? Because it's a factor. When you have that x value as the factor, you substitute into the polynomials, you should get equals to 0. Okay, so now you substitute x equals to 1 over 2 into 2x cubed minus x squared plus ax plus b. Okay, so let's substitute to 1 over 2 and then cube minus 1 over 2 and then square plus a 1 over 2 and then plus b. I should get equals to 0. Okay, why is it equals to 0? Because in the question it is stated that that is a factor of that polynomial. So when this is a factor, substitute must get equals to 0 because that is the factor theorem. Okay, so quickly let's just calculate 1 over 8 minus 1 over 4 plus a over 2 plus b equals to 0. So let's simplify this. You should get 1 over 4 minus 1 over 4. You should get a over 2 plus b equals to 0. So remember in the question, we want to calculate the value of a and b. So now you have one equation with a and b as the unknown. So you cannot solve. Okay, if you have two unknowns, you need to have at least 2 equations. So now this is the first equation. Okay, so where do we get our second equation? Is from here. Okay, from here, from the second factor. So, okay, second one, you substitute x equals to negative 1 into 2x cubed minus x squared plus ax plus b. So you should get 2 negative 1 cube minus negative 1 square plus a negative 1 plus b must be equals to 0. Why? Because this is a factor. Factor substitute must get equals to 0. So you should get negative 2 minus 1 minus a plus b equals to 0. Okay, you simplify this, you should get negative a plus b equals to 3. Okay, negative 2, negative 1, you get a negative 3. I bring it over here. So this is my second equation. We have two equations with two unknowns. So how do we solve this? Is by using the simultaneous equation. So let's just solve this. Okay, solving the first and second equation together. Okay, so this is the first equation, second equation. So I will let from the first equation, I want to let b be the subject. Here, this one, I want to let b be the subject. So now b is equal to negative a over 2. I just carry everything here to this side. Okay, and then I substitute into the second equation. Okay, second equation. So now I have negative a plus, now I have b, right? Okay, b equals to 3. So negative a plus, now b is equal to negative a over 2 equals to 3. Okay, so you solve that. Okay, if you don't know how to do, use calculator. Negative 1 minus 1 over 2. You should get negative 1 over 2a is equals to 3. Okay, this is just negative 1a plus negative 1 over 2a. When you don't have any number in front of your unknowns, means that you have a 1. Okay, so now how do we calculate a? That one, bring over there, becomes division. So press calculator only. 3 divide by, let's use this one, negative 1 over 2. Okay, so you will get a negative 2. Okay, so that is the value of a. Question asks us to find a and b. So now you substitute that value into there. Okay, so now your b is equals to negative a over 2, means negative 2 over 2. So your b is equals to 1. That's it. Okay, that's how you do. Okay, so when you have a quadratic polynomial as the factor, first step is you need to make sure you let x be the subject. So how do you let x be the subject? Is you let that one be equals to 0 first, and then you use EQN, you get two values of x. So you substitute it one by one, you should get two equations, and you need to solve simultaneously to get value of a and b. Okay, I'm going to give you 3 questions, but I will discuss one question in the second video. Okay.